Hello guys, I hope you're doing good. This new chapter is called Matter. And what you're going to do today is you're going to classify different types of matter. So you're going to be able to tell me if it's a pure substance or a mixture. And you're going to also be able to tell me what kind of mixture it is. Okay, so you can have a solution or a heterogeneous mixture. And I'm going to show you that today, the difference. Okay, matter is anything that can take up space. Anything that takes up space is matter. And volume, for example, if you put air in a balloon, it has volume. Or if you put water in a balloon, that is volume. Okay? All matter has a weight as well. So you can measure it in grams, kilograms, pounds. Okay? And that would be your mass. This is going to become important later when we do density later on in this chapter. Okay? If you want these notes, you can also pause it or take a picture. Okay? Now, matter has two different divisions. You have mixtures and you have pure substances. Let's do the pure substances first. Also, you can take a picture of this, the flow chart, or you can write it down just for future reference. You are going to need it for later assignments this upcoming week and next week's exam. Okay? All right, now matter can, anything that takes up space is matter. Let's do a pure substance first. An element. Anything on your periodic table that's all by itself, gold, carbon, copper, oxygen, chlorine, any square on that periodic table is an element. It cannot be broken down into any other further substances. It's the smallest particle you can have, okay? Okay, here are some examples of elements. Anything that's on that periodic table, every square is a separate element, okay? That is a pure substance. So if it's on the periodic table, you already know it's a pure substance, okay? Something like iron, or aluminum, or copper, okay? Even gold. Now, this is not necessarily made out of just pure gold, okay? If it was pure gold, it would bend very easily, okay, which this does not. So if you take something that's a pure substance like this, okay, like copper, it's a very soft metal. So if you had something of pure gold or pure silver, like a ring of pure silver, it would bend very easily and break very easily. Okay, this is one type of atom. It's copper. Okay? This is an element. Okay, now let's talk about compounds. Compounds are made up of two or more different elements. So if you have copper and you have chlorine, both of them are separate in the periodic table. By themselves, they're an element. But when they come together, that makes it a compound. Now, compounds can be separated. So if you take oxygen and hydrogen together and put it together, that gives you that water molecule that's on the left-hand side. However, if you go through a process of electrolysis, you can literally separate the hydrogen gas and oxygen gas. You basically break down the compound into two separate elements. A compound can be broken down. An element cannot. Here are some examples of a compound. Hydrogen and oxygen coming together gives you water. This is a pure substance. Okay, it's found uniform. Its composition's uniform. Salt is NaCl. This is also a compound. Okay, vinegar, which can be found in, your pickle jar, olive jar. This is a compound. HC2H3O2. Now, some compounds might only have two elements, like salt, that only has NaCl, and some compounds can be larger than that and have 3 or 4 compounds, even more. Okay, baking soda is a pure substance. It's a compound. Now this can be also found not just in your cakes and stuff like that, but candy, your mints, things like that. And sugar, regardless of whether it's regular sugar or a sugar square, it's still the same compound. Okay. Okay, now when we first looked at matter, I told you had two separate things, right? You had pure substances, which we just did with elements and compounds, and you also have mixtures. Mixtures is a combination of two pure substances or more. Okay? Now you can write this definition down if you want to. Now there's two different types of mixtures. You have homogeneous mixtures, or homogeneous mixtures, which is the same thing as a solution. And you have heterogeneous mixtures. Okay, and I'm going to show you examples of both. Let's discuss mixtures. You have different types of mixtures, like this makeup remover, which is made of mostly of oil and water. And you have something like a coffee. Okay. Now, this is not separated. If I turn it upside down, it's still the same, correct? This is a homogeneous mixture, okay, or a solution. Now, this is made up basically of oil and water. I'm not sure if you can see that, but if I turn it upside down, the same layers will separate. So the oil will go on top and the water will go towards the bottom. Takes a little while to separate there. Okay, now let's do some other examples, okay? If I have water by itself, it's a pure substance. Okay, you can't see that. There we go. If I have water by itself, that's a pure substance. If I add salt, which is another pure substance, or sugar, which is another pure substance, in this water and mix it, then that is a mixture, okay? Two pure substances or more combined together is a mixture. Now, this may look like a mixture. This is a chemical bottle. This is sodium hydroxide. But sodium is Na and hydroxide is OH. Okay, so all of those come directly off of your periodic table. It's not a mixture. It's a compound because you have 3 elements or more together in this solution. Okay, but if I take something like a little beaker of water, okay, and this is not going to chemically change anything. It's just a physical change when you add, color or something like that. Okay, if I put this into another beaker, it's still the same thing, right? The top, the middle, and the bottom are the same. If I add more water, it will dilute the color, but it didn't change anything. This is still H2O. This is a physical property. It's a liquid, but it's the same throughout, right? Now, if I add sugar in here, it will still be purple. However, I have a pure substance and another pure substance. This makes this a mixture, okay? If I add sugar into this water. Now, if I have the same water and I add something like sand, okay. Now, this is actually a different type of sand. This is mystic sand. If I take it out, it's still dry. Okay. You can take it out. and it's still dry. Okay, this is a heterogeneous mixture. You have different layers in here. Now if I put this and I turn it over into another beaker, let's say I do it here. See how it still separates? This is a heterogeneous mixture, okay? I can literally also separate the liquid and the solid. So here's the liquid. And especially if you can filter something out, for example, sand and water, that's a mixture, but you can separate that out. That's a heterogeneous mixture. And here is the sand. And it's dry. Okay, just like that. Okay, heterogeneous mixture. Okay, so now what's an easy way to remember that? If it's the same throughout, it's a solution or a homogeneous mixture. If you have different, let's say you can put your hand in there and get, let's say two people grab some M&Ms. Are you both going to have the same color, the same amounts? No. So that's a heterogeneous mixture. Okay, now you can also have a mixture that has a chemical reaction. Okay, I'm not sure exactly how old this vinegar is. Okay, but I'm going to put some vinegar in here. Okay, now vinegar is a pure substance, but it's an acid. Oh, that's sticky there. Okay, now bicarbonate is a base, and we're going to add this base to this acid, and this is a mixture. You see how it reacts? Okay, anytime you have gas production, that's a chemical change. Okay, now let's mix this a little bit. Okay, once it stops reacting, it will settle out, and the whatever baking soda is on the bottom and the water goes on the top. Okay, that will be a heterogeneous mixture until you have once it's completely neutral. If you have the equal amounts, you can make it into a solution. Okay, however, let's go ahead and put more powder in there. More baking soda. Okay, now that is reacting only a little bit, which means you're going to have an excess. You're going to have extra in there, right? Okay, so this will separate. The powder will sink to the bottom. The water stays on top. You have two different layers. This is a heterogeneous mixture. Okay. Now, you can have something that chemically combines, for example, like perfume. This is a mixture, but it does not separate. Okay, this is a solution. It's a homogeneous mixture. Okay, now let's take something that reacts like a chemical change. Let's do this sodium hydroxide. Okay. Now, sodium hydroxide is a base. If you have a color change, it's something. Let's color this up. Okay. When you add two or more things together, two or more substances. Sodium hydroxide was a substance, and there's the color change. This is a chemical change, okay? But it's the same throughout. Okay, so it's a homogeneous mixture. This will be a solution. Another name for homogeneous mixture. Okay, there you go. Let's do one more. Okay, now, when I put water, and I just put a simple dye, okay, just so you can see it better, and I mix this, this is not a chemical change, okay, it's just a simple physical property, okay, that color right there. Now, this, can we agree that this is a liquid? Okay, and so right here you just have water, so this is a pure substance, okay. Now we're going to add something to that. Okay. I'm going to add another substance. Okay. Now, when you, oops, that's okay. Okay, when you add two things together and it changes it chemically, that's a chemical change. This was pure water and it was a liquid, right? Is it still a liquid? After the reaction, is it still a liquid? Okay, now it's still the same throughout. It's pretty evenly distributed, so this is, you could say it's a homogeneous, right? Because it's all the same, there's no different layers. Okay, but this is a chemical change. Now, you can have something that can change the state of matter. For example, now it's a solid. Before it was a liquid, and now it's a solid. However, I can't change this back to just water and just that powder that I put in there. Okay, so that's a chemical change. However, now I can have a solid, correct? And let's do salt. Now we're going to add a different pure substance. Okay, so this is definitely a mixture. Oh, got some salt there. Bad luck. Okay, now we're going to mix the salt with the solid. Is it still a solid? Oops, I can't see. Is it still a solid? Okay, now here, I didn't change it chemically. I just changed it from a solid to a liquid. Okay? This is a physical change. Okay, it just changed the state of matter. It did not change it chemically. So, for example, if I take water and I put it in the freezer, it'll go from a liquid to a solid. But did I change anything? No. It's still H2O, correct? Right now you can change its density. For example, if I have my drink here and you see the ice cubes floating up and the rest of the soda's on the bottom, but the ice cube, it's still water, it's H2O. So when it melts, it's not going to change, it's still going to be H2O. It'll dilute the soda, but you did not change anything chemically. That's a physical change. Okay? Homogeneous mixture, heterogeneous mixture. Okay? A pure substance is something like salt. Okay? Or vinegar, that's a pure substance, okay? Or sugar is a pure substance, okay? And this is a compound. This is a compound. Now, you can have a pure substance that's just one thing, and this is an element that's a pure substance as well, okay? One element by itself is a pure substance. Two elements or more make a compound, and it's a pure substance. Two pure substances or more make a mixture, okay? And then you have your homogeneous mixture and your heterogeneous mixture, okay? And that's it. Have a great